Hi class, today we're going to learn how to diagram problems in honors physics here. The purpose of this is to be able to take information either from a graph or a word problem and be able to put it into a picture and label that picture that's going to represent the motion that's going on in that problem. It takes it one step further than just reading through a problem. For example, in this problem I have here, instead of just saying, hey, I have an initial velocity and saying that I see that the initial velocity is 10 and I can see that the final velocity is 30 meters per second, you're actually going to draw a picture of what's going to look somewhat like a cartoon with numbers and arrows labeled next to it, which shows a little bit better of an understanding of the problem. So I'm going to go ahead and do a couple examples, and I'll go through the rules here first. So you're going to draw actually two pictures for every diagram, a before and an after, or a beginning and the end. You're going to list all the possible variables that you're given in the graph or the word problem, and we're going to place arrows that are going to represent directions on all velocities and the accelerations in the problem. So let's go ahead and take a look at our first example. The example says a car is at an initial velocity of 10 meters per second and speeds up to a final velocity of 30 meters per second. It does this with an acceleration of 5 meters per second squared, and it takes 4 seconds to do this while traveling 80 meters in this time. Draw a diagram for this situation. So we can go through and we could say, all right, the initial velocity of this car, the initial velocity of this car is equal to 10 meters per second. And we could say the final velocity is 30 meters per second. And I know right here that my acceleration is equal to 5 meters per second squared. My time is 4 seconds. And my delta x, the distance it travels, is 80 meters. So you could list that out. But we're actually going to draw a picture, a cartoon, if you will, of this. So what you're going to do is you're going to draw a before, so a beginning. So I'm going to draw a beautiful car right there. So that's my car. And it is on the road. And we're going to assume the car is going to the right because anytime objects have positive velocities, which this does, we're going to assume it's going to the right. So there's the initial, and there is our final. So we're going to go ahead and label this. So the initial velocity is 10 meters per second. So right here, I'm going to, above the object or below, I'm going to write V0 is 10 meters per second. And over here at the end, my final velocity is 30 meters per second. So you label the velocities right above or below the initial and final pictures. Then I'm going to label the distance. So I'm going to go from the middle to the middle. So that is a distance the car traveled, delta x equals 80 meters from left to right. And then my time I kind of just put off to the side here, so it took 4 seconds for the car to do this. And it has an acceleration. And I usually put the acceleration in the middle of the initial and the final drawing. So my acceleration is 5 meters per second squared. Now, what I want you guys to know is that velocities and accelerations can be positive and negative, as well as the distance. And although I will usually have the object going in the positive direction for these diagrams, it is possible in some problems that it's going in the negative direction. We do want arrows, and I know we're going to get into this more later on, and you're going to maybe ask yourself why you're doing this, but it will become important in later chapters that you understand that acceleration and velocities are things called vectors, and they have directions. And like I put here, if an velocity or an acceleration is positive, we're going to say that the arrow points to the right, and if it's negative, it points to the left. So this object started here, and it was moving to the right at 10 meters per second. And here on the final picture, it is going to the right, so I draw an arrow to the right. And it has a positive acceleration, positive 5 meters per second squared. So this will also have an arrow, a direction, pointing to the right. And that is our drawing right there. So somebody could look at this picture right here that I just put in this box, and somebody could understand what is going on without even reading that example problem. They could see a car is initially at 10 meters per second. It gets to 30 meters per second. It travels 80 meters in this time. It has an acceleration of 5 meters per second, and it took 4 seconds to do so. Let's go ahead and do one more example. This is a worksheet we already did in class, and I'm just going to go ahead and diagram all the things that I can from the graph. In this case, I don't have all 5 variables like I did in the one problem I just did 2 seconds ago, but I'm going to label as much as I can. Now this is a dog that is traveling to the right. I'm going to do my best to draw a dog on the floor. So this is my beautiful dog. There we go. There's its 4 legs right there. And it is sliding to a stop over here. So there's its legs going forward. There's its ears and its tail. Okay, so there's a picture of my dog before and after. I can see from here in my graph that the dog is sliding for a time of 2 seconds. So over to the side, I'll write t equals 2 seconds. I can see that the dog traveled from pretty much the origin up to about 3.5 meters. So from middle of the dog to middle of the dog, that is a delta x equals 3.5 meters. Let's see here. The dog, I can tell from A, if I multiply that by 2, it has an acceleration of negative 1.14. So if you remember that coefficient A, if you double it, that's the acceleration. So my acceleration is negative 1.14 meters per second squared. And B represents the initial velocity. So this dog has an initial velocity of 2.94 meters per second. And that's all I can get off this graph, although I would like to have the final velocity here. I cannot get that off a position graph. I would need a velocity graph, which I don't have. So unfortunately, I don't have that information, so I don't have to draw that. So those are the 4 things I can get off the graph. The other thing is, remember to have arrows. So this dog is moving to the right in the positive direction. It's going forward and slowing down. So I'll give it an arrow going to the right. But its acceleration is negative. And if you have any negative acceleration or velocity, you have to give an arrow pointing to the left. And there you go. That's my final diagram. You can see it took 2 seconds for the dog to run 3.5 meters. It's going to the right at 2.94 meters per second and slows down with an acceleration of negative 1.14 meters per second squared. That is it.